let's talk about the difference between mass number and atomic mass. These things sound very similar, but they're actually very different. Just so you know, atomic mass can go by other names. Sometimes it's called average atomic mass, or relative atomic mass, or even atomic weight. Maybe your teacher calls it one of these. For our purposes, in this video, we're just going to call it atomic mass. So, we're talking about the difference between these two things. Let's start by talking about mass number. So up here, I've got two atoms. They've got protons and neutrons in their nucleus, and I'm particularly concerned with the number of protons and neutrons that there are. So this atom over here has 5 protons. The protons are these red circles. We can count them up. 5 protons, and the neutrons are these blue circles. We could count them up. We got 5 of those. This atom over here also has 5 protons, but it's got 6 neutrons. So, mass number is the number of protons plus the number of neutrons. So this atom here has a mass number of 10. 5 plus 5. And this atom over here has a mass number of 11. 5 plus 6. Mass number tells us how many protons and neutrons are in the nucleus of an atom. But it's also important because it gives us an idea of how much the atom weighs. You might remember, we've said before, that one proton or one neutron weighs about 1 AMU, 1 atomic mass unit. So, if you have a mass number of 10, 5 protons and 5 neutrons, your atom is going to weigh about 10 AMU. If you have a mass number of 11, that tells you that the atom here weighs about 11 AMU. These atoms both have electrons, but electrons are so tiny and they have such a small amount of mass that we don't even worry about the mass of electrons when we're weighing up stuff to determine how much the larger atom would weigh. So 10 AMU, 11 AMU. So that's mass number. Protons plus neutrons, and it gives you an idea of how much the atom weighs in AMU. Now, let's talk about atomic mass. You might notice that both of these atoms have the same number of protons in their nucleus. 5 protons here and 5 protons here. This means that they are the same element, right? Because the number of protons an atom has determines what kind of an element it is. So, we can look on the periodic table to find out what element these atoms are. And it turns out that they're boron, because boron up here has an atomic number of 5. 5 protons and your boron. So, both of these atoms are different versions of boron. They're different isotopes. An isotope is a word that just means a different version of an atom that has the same number of protons, but a different number of neutrons. We can give distinct names to these two isotopes or versions of boron. This atom over here is an example of boron 10 because it has a mass number of 10, 5 plus 5. And this atom here is an isotope of boron called boron 11. 5 plus 6 has a mass number of 11. So, there are billions and trillions and gazillions of boron atoms in the world. If we could pick one up at random, it could be either one of these two types. Okay, it could be a boron 10 atom with 5 protons and 5 neutrons, or it might be a boron 11 atom with 5 protons and 6 neutrons. So boron comes in these two versions. Now the thing is, there is not an equal number of boron 10 atoms and boron 11 atoms. In fact, if we pulled 50 boron atoms at random and represented them here, we'd see that the majority of the boron atoms are boron 11, which I'm indicating with little orange circles here. Okay, most of them are boron 11, and only a small minority of them are boron 10 atoms. We can look at this on a pie chart just to get this point home, and you can see that the vast majority of them are boron 11 with a smaller amount that's boron 10. If you crank through the math here, you'll find out that about 20% of the boron atoms in the world are boron 10, whereas 80% of them are boron 11. This leads us to the idea of atomic mass. Now, atomic mass asks what is the average mass of a boron atom. All right? We've got these two types of boron atoms. We've got boron 10 that weighs 10 AMU. That's what its mass is. And we've got boron 11, which weighs 11 AMU. That's what its mass is. But here's the thing. There's only 20% of this guy and 80% of this guy. So now we're asking, got these two types of boron, what is the average mass of a boron atom? Now, you might think average and say that's pretty easy. I know how to take an average. This guy weighs 10, this guy weighs 11. So why don't I just add the two of them up, 10 plus 11, and divide by 2? And then I'll get 10.5, right? That's how I take an average, okay? No, it's wrong. That is one way that you can take an average, but it won't work here. And the reason why is because this type of thing, added up and divided by 2, assumes that we have the same amount of both of these. If we had 50% boron 10 and 50% boron 11, then we could just add them up and divide by 2. But we can't do that because we have different amounts of these two types of atom, okay? And we have to come up with a mathematical equation that's more complex than this to take into account the different amounts that we have of these two atoms. Here's how we do it. We take the fact that there are 20% boron 10 atoms and that they weigh 10 AMU each, so 20% times 10 AMU. And then we add that to 80%, which is over here, times 11 AMU. And we do that math, we have to convert the percentages into decimals, but when we crank through this, we end up with 10.8 AMU. And this tells us what the average weight of a boron atom is, taking into mind that only 20% of the boron atoms out there are boron 10, and 80% of the boron atoms out there are boron 11. Now check this out. The number that we get here, 10.8 AMU, is what's the bottom of this element name on the periodic table. So that's what this number is. It's the atomic mass that tells you what the average weight of one of these boron atoms is. Now we said we had these two different types that weigh 10 AMU or 11 AMU. Look at the average. The average is 10.8, which is much closer to 11 than it is to 10. And that makes sense, because since we have so many more of these and they weigh more, the average for these two types should end up closer to this, just because we have so many more of them. So that's how we determine what atomic mass is. Just to review these two things. Mass number is a number of protons and neutrons in a particular atom or in a particular isotope, and from the atomic number you can figure out how much the atom weighs in AMU. But now atomic mass looks at all the different types of isotopes for a particular element, in this case boron 10 and boron 11. It takes into account the amount of each that you have, also known as the abundance, how many of them there are, and then you do this math taking into account the abundance to find the average mass of all of the different types of boron. So that is the difference between mass number and atomic mass. If you want to learn more about how to calculate atomic mass, I've got videos on that.